Today we're solving problem 16 from the Spring Amc 10B from 2021. Call a positive integer uphill an uphill integer if every digit is strictly greater than the previous digit. For example, 1, 3, 5, 7, 89, and 5 are all uphill integers, but 32, 12, 40, and 466 are not. How many uphill integers are divisible by 15? Now, let's just write out what they're saying, their examples. So 1, 3, 5, 7, uphill integer, 89, uphill integer, 5, uphill. Now what this means is that, so let's just take this first number, 1, 3, 5, 7. The first digit is 1. The second digit has to be greater than 1, or the first digit, which is, in this case, 3. And 5 is greater than 3, so this checks out, and the last digit, which is 7, is greater than 5, so that works. But the ones that don't work the ones that don't work that they give us for examples are 32, 12, 40, and 466. Because this is not increasing, this is going up and going down, and then for 32, this is up and down. So immediately we realize that the last number cannot be a 0. That's good information. So what we want to know is how many uphill integers are divisible by 15. We know that for it to be divisible by 15, it has to be like, so let's just say something that is pretty obvious. So it can't be, so for an integer to be number to be divisible by 5, it has to end in 0 or 5. That's for it to be divisible by 5. But since in this case we're dealing with what they call an uphill integer, 0 is out of case. So we're only wondering if 5 is the case. Now, it has to end in 5, and the sum of the digits, it has to equal a multiple of 3. So it can't be one digit, because then it wouldn't be divisible by 15. For 2 digits, there's going to be 15 and 45. Those are the two uphill integers for that set. Now for 3 digits, so we can obviously put in 5 at the back. Now we could have, like, what could we have? We could have, so this has to be a multiple of 3, so like, let's just consider the case where the first is 1. 1 plus 5 is 6. It can't be 0 here. It can be 3. Now, if it ends in 5, can it be 2? The only possible formation for when it is 2 is 2, 4, 5. But this is not divisible by 15, since the sum of the digits is not a divisor of 3. So it has to be like, well, least case scenario, it can be 3 something. Well, we can actually achieve this, because this is 3, 4, 5. That works. Okay. And so for the earlier case, if it starts with 2, both cases wouldn't work, because the sum of the digits would not be divisible by 3. So these are the only 2 digits that work for the 3 digits. For 4 digits, so 5. Now, this sum of the digits is going to be 7 plus 5. This sum is 12, and this sum is 9. If we can keep it at 12, we want to have a low number. Say this is 1. 1 plus 5 is going to be 6. We want a sum of 6 in the middle. Is that possible? 2 and 4. Yes. Now, is there any other combination for 4 digits? Apparently not, because it can't go up by 5. It can't go above 5, and it wouldn't work any time else. So let's consider 5 digits. And we are nearing it. So it could still be 5, and since we're considering, these numbers, it could be 1 and 5. Now the sum, what could the sum be? The sum, it could be it has to be divisible by 3. So it cannot, if it's not 12. It could be 12 or, yeah, 12. 12 works. And then the next divisor of 3 is 15. So, yeah, we can do 15. This is already going to be 6, so we can knock out 6. The sum of these digits is going to be 9. Well, 2, 3, 4 is going to work. Yeah, that works for 5 digits. Now, is there any 6 digits? There is none. So we can just add up all these cases. This is 1 plus 1 plus 2 plus 2. Or our answer, 6. And we are done.